Key risks of neutral conductors. This document outlines the key risks associated with neutral conductors in electrical systems. It discusses the hazards of open neutrals, overvoltage, overheating, failure of protective devices, unintended current paths, shared neutrals, improper neutral to ground connections, corrosion, improper neutral sizing, electrical noise, and ground loops. The document emphasizes the importance of regular inspections, proper sizing, and safe handling of neutral conductors to prevent electrical shocks, appliance damage, and fires. Electric shock hazard, open neutral. An open neutral is one of the most dangerous risks in electrical systems. When the neutral conductor becomes disconnected or broken, it loses its reference to ground. In a multi-wire circuit, this can cause the neutral to become energized, leading to an electric shock. This is especially hazardous for electricians working on circuits that appear to be de-energized, as they may unknowingly come into contact with a live neutral conductor. Overvoltage and appliance damage. Unbalanced loads or harmonic currents can cause overvoltage in the neutral conductor. This occurs when some circuits are overloaded while others are not, leading to excessive voltage in the system. Sensitive electronics and appliances may be damaged by these voltage surges, and in some cases, it can even pose a fire risk. It is crucial to balance the load across circuits to prevent overvoltage in the neutral conductor. Overheating and fire hazard. Undersized neutral conductors or poor connections can result in excessive heating of the conductor. This occurs when the conductor carries more current than it's rated for. Overheated neutral conductors can degrade the insulation, leading to short circuits and increasing the risk of electrical fires. Regular inspections of neutral conductors and connections are essential to identify and address potential overheating issues. Failure of protective devices. An open or faulty neutral can prevent circuit breakers from tripping when there's a fault, leaving the system vulnerable. Circuit breakers are designed to disconnect power in the event of a short circuit or overload, but an open neutral disrupts the flow of fault current, which can prevent the breaker from activating and increase the risk of electrical shock or fire. This can lead to a dangerous situation where a fault goes undetected, potentially causing significant damage or injury. Unintended current paths. If the neutral conductor is compromised, electricity may find an unintended path to complete the circuit. This could be through metal pipes or even people. These unintended current paths are extremely dangerous, increasing the risk of electric shock and potentially starting fires. It is essential to ensure that the neutral conductor is properly grounded and protected to prevent unintended current paths. Shared neutrals in older installations. In older buildings, it's common to find shared neutrals in multi-wire branch circuits. If one of these neutrals is improperly disconnected, it can still carry current from the live circuits, creating a shock hazard. This is especially dangerous when working on circuits that seem turned off but still have an energized neutral. Extra caution should be taken when working with shared neutrals to avoid electrical shocks. Improper neutral to ground connections. Improper or multiple neutral to ground connections can cause the neutral conductor to become energized. This can lead to electric shock or equipment damage because the neutral, which is normally safe, becomes a potential hazard. It is crucial to ensure that neutral to ground connections are properly implemented and maintained to prevent the neutral conductor from becoming energized. Corrosion. Neutral conductors are also susceptible to corrosion, especially if they are exposed to moisture or harsh environments. Corrosion increases the resistance in the conductor, which leads to overheating and the failure of the neutral, creating a fire hazard and jeopardizing the safety of the electrical system. Regular inspections and maintenance of neutral conductors are essential to prevent corrosion and ensure the safety of the electrical system. Improper neutral sizing. Neutral conductors must be properly sized to carry the total load of the circuit. If the neutral is too small or undersized for the current it needs to carry, particularly in systems with harmonic currents, it may overheat. This poses a fire risk and can cause the conductor to fail. Proper sizing of neutral conductors is crucial to prevent overheating and ensure the safe operation of the electrical system. Electrical noise and interference. Harmonics from sensitive electronics like computers, LED lights, and variable frequency drives can distort the neutral conductor. This can cause electrical noise, which may lead to equipment malfunction, data corruption, and signal distortion. Ensuring the neutral conductor is properly sized and maintained can help minimize these risks. Filtering and other mitigation techniques may also be necessary to reduce harmonic distortion. Ground loops. Improper grounding can create ground loops, which introduce unwanted currents into the neutral conductor. These ground loops can interfere with electronic equipment and data systems, leading to operational issues and safety risks. It's essential to ensure that grounding is properly implemented in the electrical system to avoid these problems. Proper grounding techniques, such as star grounding, can help prevent ground loops. Conclusion. In conclusion, while neutral conductors play a crucial role in electrical systems, they also come with significant risks that need to be carefully managed. Regular inspections, proper sizing, and safe handling of neutral conductors are vital to preventing hazards like electric shocks, appliance damage, and fire. Always consult a licensed electrician if you are unsure about the condition of your electrical system. Stay safe.